For number 21, we can see our LCD is x squared, and that means that the only restriction would be that x is not allowed to be 0. Multiplying both sides by x squared. This x cancels with one of those x's, and so we're left with 1x, and x times 2 is 2x. On the right side, the x squared cancels here with the LCD, so we just have 1 times the denominator. And then this x squared cancels, and so we get that other time, the other denominator. And so we have one equation. It's got quadratic, linear, and constant terms, so we have a quadratic equation. We're going to gather all the like terms on the right-hand side first before we move any terms over. So 35x plus 3x is 38x. 60 times plus 3 is 63. And then, so we're going to go ahead and subtract 2x from both sides, and we're going to get 0 equals 5x squared plus 36x plus 63. That might seem a little daunting here, but as I look at I'm looking at the solutions again, and I see we don't have any radicals in there. In fact, there's no radicals in any of these problems as far as the answers go. So every single time you get a quadratic equation, it will factor. And I find that many students need practice with this kind of factoring. So just to give you an idea, 63, just to help you through factoring if you're having trouble when the leading coefficient is something other than 1, like we have here, I'm going to go ahead and list the factors of 5x squared. Well, those are easy because there's only one combination, it's 5x and x. But we have other combinations with 63, and the better you are at your multiplication tables, the better off you're going to be at factoring. 1 times 63, I'm going to list all the factors of 63. 2 doesn't go into 63 because it's an odd number, but 3 goes into 63 because 6 plus 3 is 9, and 3 goes into 9. Well, 3 times 21 would be 63. 4 doesn't go in, 5, 6, 7. 7 times 9 is 63. 8, so once you get to this number, 8, so 8 doesn't go into 63. 9, once you get to that number, you're done. So we've listed all the factors of 63. Well, if I try 7 and 9, let's visualize that. If I put a 7 here and a 9 here, so 7 and 9, if I put a 7 here and a 9 here, that means 35 and 9. That's never going to make 36. If I put a 9 and a 7 here, and I get 45 and 7, that's never going to make 36. So it can't be those two. So if I try a 21 and a 3, I can't put a 21 there because 5 times 21 is going to be way too high. So if I put a 21 there and a 3 here, then I get 5 times 3 is 15, and I get 21 times x is 21 times 1 is 21. 15 and 21 make 36. So I get 21 there and a 3 there, plus, so since these two terms are both positive, the two signs in the parentheses have to both be positive. And so I have found both factors. 5x plus 21 times x plus 3, because we have 15x plus 21x, that's 36x. 21 times 3 is 63. So that is one of the most difficult factoring problems that we've had so far. But nevertheless, when we set each factor equal to 0, we subtract 21 from both sides, and then we're going to go ahead and divide both sides by 5, and we get x equals negative 21 over 5. And over here, x plus 3 equals 0 means that x is equal to negative 3. Not restricted, so we have both of these numbers as our solutions. So let's try to get number 22 in here as well, under 6-minute mark. So we have LCD for number 22 is x squared. All three denominators go into x squared, which means, again, the restrictions are that x is not allowed to be 0. Multiplying both sides by x squared, we get 1 plus x times x plus 5 equals x squared. Simplifying the left side, x squared plus 5x equals x squared. Subtracting x squared from both sides, that's kind of a nice little deal there, because these cancel each other out. So we get 0. So we get 1 plus 5x is equal to 0. Subtracting 1 from both sides and dividing both sides by 5 gives us x equals negative 1/5. And is that really the answer? Yep, that's the answer.